This LOS is calculate and interpret covariance and correlation. This is another LOS that we see in quants that we flash forward to the portfolio management, in particular the reading risk and return part 1, and we see it again. There's an LOS there, calculate and interpret the mean, variance, and covariance or correlation of asset returns based on historical data. So given a portfolio with N securities, the expected return on the portfolio is the weighted average of the expected returns on the component securities. So that's easy. You have a asset portfolio, a stock and a bond, and it's 70% stock, 30% bonds. Calculating the expected return is easy. It's just 70% on stocks times the expected return on the stocks, plus the 30% on the bonds times the expected return on the bonds. It's just a weighted average. We've seen that before. However, when we get into the variance or variability, standard deviation of a portfolio, it's not using the weighted average. And this is why we need to go through the covariance and correlation. Okay? So covariance is a measure of how two variables move together. Stocks and bonds don't move together in the same direction. So the values range from minus infinity to plus infinity for covariance. Units of covariance are difficult to interpret, therefore. If they say, oh, the covariance is 492, what is that really telling you? Covariance is positive when the two variables tend to be above their expected values at the same time. So what we do with correlation is a number between -1 to +1 that measures the co-movement, the linear association between two random variables. So it's easier to understand. The correlation coefficient is a number between -1 and +1 that measures the consistency or tendency for two investments to act in a similar way. So now if you say, oh, the correlation is 0.96, you know that they move in a very similar pattern. If you say the correlation is -0.75, you would know that they move in almost opposite directions. Okay, so that's why correlation is much easier to understand and interpret, and that's similar to what we use standard deviation rather than variance, because variance, you can say, oh, the variance is 195. Well, what does that tell us? But when we take the square root of the variance and put it into standard deviation, then it's in the same measurement scale as that we're looking at, say returns. We can understand, oh, the standard deviation of returns is 3%. We understand that. So similarly, we can do the calculations for covariance, but it becomes more meaningful to us when we then do an additional calculation and calculate the correlation coefficient. Okay? Okay, so here we have the formula for covariance. It's the sum of x minus x bar times y minus y bar divided by n minus 1. Okay? And down here I just said this is pretty easy to understand, because remember our formula for variance of a sample? It was x minus x bar squared over n minus 1. Well, x minus x bar is the same as x minus x bar times x minus x bar. So that was dealing with the variance of just one variable, like for example the stock. But now if you're looking at the stock and the market, you'd have two variables, an x and a y. So what we're doing is the covariance, we're just substituting that second term from x to y, and that's how you get the covariance. It's very easy. So x minus x bar times y minus y bar, the sum of that, divided by n minus 1. So I've used this example before, and I'll use it again. So this is looking at the stock return of GE from December 2003 to December 2004. And then we're looking at the S&P 500, so that's just the closing level. And at that time, there was no dividends paid on the GE stock. And so this comes up later on in portfolio management. We need to calculate the beta of the GE stock. And the beta is covariance of the stock over the variance of the market, okay? And so we need that covariance to calculate a beta. So now we're looking at the calculation of the covariance. So as we said, it was the sum of x minus x bar times y minus y bar over n minus 1. So remember how we did that? we calculated our X bar, which was our average return of the stock, and we calculated our Y bar, our average return of the market. Then we did X minus X bar. When we squared that and added it all up and then divided by n minus 1, we were able to calculate the variance, okay? And square root of the variance was the standard deviation. Same thing here for the market. We calculated Y bar, then we did Y minus Y bar, and you can see we weren't doing any totaling on that. And when we squared that, Y minus Y bar squared, added them all up, and then divided by n minus 1, we've got our variance, okay? The sum of Y minus Y bar squared over n minus 1 is get our variance. The square root of our variance gives us our standard deviation, okay? So this is the important part here, the covariance, and I put this in kind of the pink color. We're multiplying column 1 times column 2, which is X minus X bar times Y minus Y bar, okay? So you can see 7.11 times 0.99 is going to equal 7.02. Negative 4.75 times 0.48 is going to equal negative 2.28, etc. So we're doing X minus X bar column times Y minus Y bar column. And then what we're going to do is we're going to sum all that up, okay? And that gives us just a number like 43, and that's what we said. And then the covariance, 43 divided by n minus 1 gave us 3.9. But that's not really telling us that much until we then calculate the correlation between the two. However, that covariance number is important because we can calculate then the beta. The beta is the covariance of the stock in the market divided by the variance of the market, and we get a beta of 0.89. So as we might expect, GE has a little bit less risk than the market in general, but they're moving in a similar direction. So the LOS does say to calculate the covariance, so this is a nice little practice problem to check your understanding. An analyst has gathered monthly returns for two stock indexes, A and B. So we have the 4 months. We have the returns for index A, month 1, negative 6.4%, month 2, 6.6%, month 3, 12.9%, and month 4, 3.2%. Then we have the returns for index B, month 1, negative 6.2%, month 2, 19%, month 3, negative 7.7%, and then month 4, 4%. The covariance between index A and index B is closest to A, 10.37, B, 13.82, or C, 19.64. Okay, I'd say in the CFA continuum of things, this is a fairly easy question because it's very mechanical. It's just that there's a lot of calculator keystrokes that you need to do in 90 seconds, so speed is a skill gets rewarded, and you need to be fairly accurate. So let's start with the formula for covariance. It's the sum of X minus X bar times Y minus Y bar over n minus 1. Remember from my previous example, GE and the S&P 500, that was my column 1 and that was my column 2. I was multiplying the two together, right? And then I had my final column over here, and I was going to sum that up and then divide by n minus 1, and that gives me my covariance, correct? So what did we need to do here? We need to calculate our X bar and our Y bar first, and that's just the average, which is very easy. So I'm doing that down here. So negative 6.4% plus 6.6% plus 12.9% plus 3.2% divided by 4, and that's going to give me an average monthly return for index A of 4.08. Same thing over here. We're going to add negative 6.2% plus 19 minus 7.7% plus 4% divided by 4, and we're going to have an average return of 2.28%, okay? And then we have to use our formula there, covariance, the sum of X minus X bar times Y minus Y bar, okay? So here you can see that's X here, that's my X, and my X bar, this is my X bar, 4.08. So X minus X bar times Y minus Y bar. Here's my Y, and here's my Y bar, which is 2.28, correct? And so you can see going back to my example with GE and the S&P 500, that was column 1, that was column 2, and we're multiplying the two together to get this number for the following column. And then so it's just plus, again, x minus x bar times y minus y bar, plus x minus x bar times y minus y bar, plus x minus x bar times y minus y bar. And that's going to give us, when we add all that up, and so you can see that's a lot of calculator keystrokes. You're just cranking it out, and you need to be accurate. You're going to get 41.47. And then, so don't forget, you're dividing by n minus 1. So 41.47. So when we totaled all that up, that was 41.47 divided by n minus 1, which is 3. We get 13.82. So the correct answer was B. Not a very difficult question, very mechanical, but as you can see, a lot of calculator keystrokes that you need to do in 90 seconds, so you want to be very fast and very accurate with your calculator. Okay, this slide is a nice to have, not a need to have. It's not in the CFA curriculum textbook. This is, I put this in myself, and the source was the JP Morgan Guide to the Markets. If you just Google search that, you can find a latest edition on the internet. And this is a periodic table of returns, and it helps consolidate your understanding with regards to covariance and correlation, okay? And so when you look at these tables at first, it looks a little bit confusing, but what is it showing us? So first of all, it's showing us from 2000 to 2015 the average returns and also the volatility. So you can see from 2000 to 2015, the asset class, and it's showing us different asset classes that had the highest average return was REITs, real estate investment trust, also had the higher volatility. So what are the different asset classes that we're looking at in this periodic table of returns? We've got emerging market equities, as we would expect, fairly high volatility, but also fairly higher return. We have the real estate investment trusts. We have small cap stocks, again, traditionally more volatile, but with should be higher returns, correct? So, and that's kind of matching up, higher returns, higher volatility. We have developed market equities. We have commodities. We have large cap stocks, high yield bonds. And then what we have here, asset allocation, that's the portfolio. And that's what I did with this black line showing the, this is a portfolio. And in their guide to the markets, they'll show you what the weightings were on this and what exactly benchmark indexes they were using. For example, the emerging market equities would be the MSCI Emerging Markets Index, for example, okay? And then you've got some fixed income here, and then of course cash. You're not going to have much return on cash, and you're going to have very low volatility, all right? So just, this is getting back to the correlation and covariance. If we just looked at two asset classes, for example, small cap stocks and REITs, you can see in 2000, REITs had a better return, positive, very good return, and small cap stocks were negative. But then in the following year, REITs were up, small cap was up. Following year, small cap was down, REITs are up. Following year, small cap, whoa, way up, 47%. Where's my REITs? REITs are down a little bit. So they're not moving in the same direction. You can see that. So if you just follow the variability on the small cap stocks, higher peaks on the high, lower peaks on the low than the portfolio, because when we build a portfolio, we're diversifying our risk. We're combining assets that have lower correlations together, which we're going to see later on. But I just put this in this slide in now because we're talking about the covariance and correlation. Okay, so you can see 2013 is very high return on the small caps, and where are those REITs? Oh, the REITs are down here. So the asset classes are not moving in the same directions at all times, and that's very important when we start to build portfolios. As I said, follow the performance of this portfolio that they've built, and it's moderated. It's falling, in between. It's less volatile than the individual asset classes. So this slide is also a nice to have, not a need to have, but it's the correlation of returns and annual volatility. And so again, the source was from the JP Morgan Guide to the Markets, and I circled one here. I'm not going to spend a lot of time on this slide, But you can see this is Europe, Asia, Far East. So that would be like an MSCI index for stocks. And you can see actually, and this is looking for the period of June 30th, 2006 to the end of March 2016, so a 10-year period. There's actually negative correlation between bonds and stocks. And so again, it's going through these different asset classes: large cap stocks, Europe, Asia, Far East, emerging market equities, bonds, munis. Here's the real estate investment trusts. You can see real estate investment trusts, fairly higher correlation with the stocks, because real estate investment trusts are listed on markets, so rising tide lifts all boats. But this is important, understanding the correlation matrix again when we start to build our portfolios. But we'll be coming up to that later on in the portfolio management. But this LOS is talking about the calculation of covariance and correlations. It's the foundation for the portfolio management. So I just put these two slides in here to help consolidate your understanding a little bit. Okay, this LOS again was calculate covariance and correlation. So we did the covariance, which is the sum of x minus x bar over y minus y bar divided by n minus 1. That's done. So correlation, and that's why we calculated the covariance first, because correlation is covariance of x and y divided by the standard deviation of x times the standard deviation of y. And here I'm just writing it a different way, because different texts you see it sometimes as COR, sometimes you see it as a big R. That's the same thing. Those are just different nomenclatures, you know. And then, so once we've got the formula for correlation, covariance divided by standard deviation times standard deviation, we can do the algebra, move the standard deviations over. We can see standard deviation of x times standard deviation of y times the correlation equals our covariance. So a little bit of a different formula for covariance if we know, and again, this is a 1 variable, 2 variable, 3 variable, 4 variables. Given 3, solve for the fourth, which is a classic CFA 101 type question. So I've just spun that over, and you can see the covariance is standard deviation of x times standard deviation of y times the correlation. And we remember that correlation is a number that can go from -1 to +1, and that's very important, because later on when we look at the formula for the variance and standard deviation of a portfolio, we're going to be using the covariance. And because we can rewrite the covariance formula in this method, that includes correlation, which can go from -1 to 1, if the number is less than 1 or even in the negatives, we can see that portfolio standard deviation is going to go down. But don't worry about that. We're going to come to that in a later LOS, but this is what we're moving towards. So again, we know our calculation for covariance. Correlation, covariance divided by standard deviation of x times standard deviation of y. And because we have that, we can rewrite our covariance in a second method. So we're finishing this LOS with one last slide, which is a practice question. If the standard deviation of stock A is 10.6%, the standard deviation of stock B is 14.6%, and the covariance between the two is 0.015476, what is the correlation coefficient? A, 0.0002, B, 0, or C, +1? Pretty easy question actually. So it's asking for the correlation coefficient, which we know is the covariance of x and y, divided by the standard deviation of x times the standard deviation of y. So they've given us the covariance, and they've given us the standard deviation, so you just plug it in, and this is giving us an answer of 1, so the correct answer was C. Now the only thing to be wary of is that here they gave us the standard deviations. Of course they could give us the variances. So to get the standard deviation, you would take the square root of the variance. That's number one. You know, you always have to be looking at what are they giving you, standard deviation or variance. Number two, this is one thing that they like to do. They like to combine percentages with with decimals, okay? So in this case, they gave you the covariance is 0.015476, but they gave you the standard deviation in 10.6%. Sometimes they'll give you the standard deviation as 0.106. and sometimes it's 10.6%. So they like to jumble up, or sometimes they're using decimals. That's why you need 5 decimals on your calculator, by the way. Sometimes they're giving you percentages. You know, what I used to always do, my exam tip is I always kept things in decimals. I always ran 5 decimals on my calculator. So no matter how the data, and we're going to see this in other types of questions, so no matter how the data was presented to me, I would always use one format, because sometimes there's some choices. You can use whole numbers or you can use decimals. My preference was to always keep things in decimals. That way I never got confused. So that's my last little exam tip. This question was easy, and that's the last slide for this LOS. Thank you very much.